My dear students, this is the problem asking 2024 latest JEE mains question. So in this question, he has given the numbers and is asking us to find out the significant figures. To get the significant figures, what you have to do, you should know some 5 rules here. What are the 5 rules? Let me discuss one by one. So here, first rule is all non-zero digits are significant. Means other than 0, any number is there, it is significant. For example, irrespective of decimal point is there or not there, doesn't matter. So first is having 3 significant figures. Significant figures means we can rely on them. They are reliable numbers. Significant figures is nothing but they are the numbers which can be reliable, which we can rely on them. So next here, there are 4 significant figures because there are 4 non-zero digits. Here there are 5 significant figures because 5 non-zero digits. So first rule says that all non-zero digits are significant. They are significant figures. Second rule says that a 0 is present between non-zeros, it will become significant. If 0 is present in between non-zero digits, it is said to be significant figures. Just like in rice, in between the rice grains, if you keep some stones, they will get significance. They will be weighed, they will be purchased at the rate of rice when you keep some stones in between the rice also. So even stones will become significant when they are entering into rice. Similarly, zeros between non-zeros are going to become significant figures. So here zeros are valuable, they are reliable. We can write now. Here these are 3 significant figures. Here there are 4 significant figures. Here there are again 4 significant figures because zeros are significant. Their significance is because they are present between 2 non-zero digits. That is 4 and 4. Next, third one, if 0 comes left of non-zeros, then it is never significant. That is the rule here. So even though 0 is present here, 0 point or 0, that is not going to be significant if it is left of non-zeros. So even though 0 is present, it is having only just 3 significant figures. It is having 2 significant figures. Even though there are 3 zeros, it is having only 1 significant figure here. That's it. Next, trailing zeros after decimal points are significant. If any 0 comes here after decimal point, then it is having significance. It is said to be significance. We have to rely on that. It is a reliable digit. Even 0 becomes reliable when it comes after non-zero and that too decimal point is present. That's why it is having 4 significant figures. It is having 5. It is having 6. Even though there are 3 zeros after decimal point, they are having significance. They are reliable. So that's why this is called as the 4th rule. Okay. The 5th rule says that even though there is exponential digits here, for example 10 power minus 2, 10 power 4 are present here, they are not powers are not significant. Only this digit is valuable. It is reliable. So therefore significant figures in this case is 3 and in this case also it is going to be 3. So after knowing all these rules, we can solve this problem here. For example, here zeros are present between non-zeros. So it is having significance. So it is 4. Next here, if you observe B, how many significant figures are there here in B? So B 0 1 0 1. Okay, left 0 is not significant, but the middle 0 is going to be significant. That means it is going to be 3. Okay, its value is 3. Now here zeros are present after non-zeros and decimal point is there. So it comes under the 4th rule. So therefore it is having 6 significant figures. It is going to be your answer now. So zeros left of non-zeros are not significant, whereas zeros in between non-zeros are significant again. So it is having 2 rules are combined together. So it is having, this is the option here. So first one is 4th one, second one is 3rd. First is 4th, second one is 3rd, and C, 3rd one. This is B. A is 4, B is 3, C is 6, and D is going to be 3rd one. That's it. B is 1. B is 1. A is 2 here. Okay. So like this we can find out here. No. So this is going to be our answer. Thank you. My dear students, you can see the importance of these questions. It is asked in JEE Mains 2020, 2022 also it is asked, but the difference is here it is 2 given, here 2 is not present. But either 2 is present or not, 2 doesn't have any dimensions because it's a numerical value. Let us see this one also. Here also epsilon naught e square or half epsilon naught e square. As there is no dimensions for half, it is not counted. Here 2 also not counted. But these 4 formulas are having a common thing. What is that common thing? These 4 formulas belongs to electromagnetic wave. Okay? And what is that electromagnetic wave explaining here? It is the energy density of an electromagnetic wave. Energy density of an electromagnetic wave. Electromagnetic wave is having electric wave as well as magnetic wave. So, energy density, either it is electromagnetic wave, either it is an electric wave or a magnetic wave. The formula is going to be same. Half epsilon naught e square, which is equal to half b square by mu naught. So these two formulas are same. They are called as energy density formulas. Epsilon naught e square or b square by mu naught. It is a formula for electric wave. This is the formula for a magnetic wave. Whatever it may be, the dimensions are same for these two formulas. What is the meaning of energy density? Energy density is nothing but energy divided by volume. Energy divided by volume. You know energy or work done, both are having same formulas. What is that? It's very familiar that energy means ml square t power minus 2, whereas the volume is nothing but L cube. That's it. So here L square and L cube are getting cancelled. So what is left now? So energy density formula is nothing but m. This L comes to the numerator, becomes L power minus 1 and T power minus 2. That's it. Hope you have enjoyed this class. Thank you very much. Have a nice day. My dear students, after doing thousands of problems, we physics lecturers will understand some logic for solving the problems, some shortcuts and logics which may create magics. If you don't learn this type of magic, your life end up with tragic. So what is the magic behind this? So you might have seen that he is asking us to find out the percentage error. If you observe here, he is asking us to find out the percentage error in this problem. But what is the simple logic behind that? The percentage relative error will be very close to the values which are given here. If you observe these values, okay, so that will be very close to all these values. Percentage error will be very close to these values. This is the logic behind that. If you learn this logic, it will be highly magic. Super. You will appreciate what type of simple method it is. So what is the simple logic? That your answer will be very close to what we have said. So all these are very close to 1.6. Very close to 1.6. So one thing is that instead of doing all this long process and after that you are getting 1.6 percentage, why don't you understand the logic that this type of problems will give the same results? If you want, I can show you one more example. Comment me below, I will tell you one more example of this type. So your answer, without doing, just by observation, you can tell that the answer is 1.6, which is very close to all these values which are given here. Okay.